Hey everybody, Chris McClure here. We're going to do a quick review of absolute values and then how to solve equations involving absolute values. Right? What is absolute value? Well, that tells you how far that you are from zero. So if this is 0 and this is -4, then the absolute value of -4 is going to be 1, 2, 3, 4 units. So the result of taking the absolute value of number is always going to be either a positive number or 0. Of course, the only reason that you would have 0 as the absolute value of a number is if that number that you're taking the absolute value of is 0. Okay? So now, if we say that the absolute value of a number is, say, a, well, that means that either your number is a or it could be negative a. So, for example, if I say that absolute value of x is equal to 2, for example, I'm thinking of a number whose absolute value of 2, what is x? Well, it could be that x is equal to -2, or it could be that x is equal to +2. Okay? And if I were to say that the absolute value of some number called x minus 3 is equal to 10, it could be that x minus 3 is equal to +10, or that x minus 3 is equal to -10. So you have two equations to solve. The first equation, of course, means that x is equal to 13. Second equation means that x is equal to -7. So you have two solutions to this equation. If you have that the absolute value of 2x plus 1 is minus 3 is equal to 7, well, treat the absolute value bars as grouping symbols. And first move the 3 over to the right-hand side by addition. So you add 3 to both sides, and then drop the absolute value bars, and then you say that 2x plus 1 could be equal to +10 here, or to -10 there. And you solve each one of those individual equations. For the first one, you subtract 1, and then divide by 2, so you get 9/2. For the second equation, you subtract 1, divide by 2, so you get x equals -11/2. So you have these two solutions, and there's your solution set. Okay? Let's solve inequalities involving absolute values. All right? If I were to say that the absolute value of some number is less than or equal to 3, all right, what could x be? Well, as long as the absolute value of x is less than or equal to 3, then we have solved the inequality. Now, that could mean that x is any real number between -3 and +3, including -3, including +3, and any number in between. So x could be -2, could be -π/2, or 0, or √2, or any other number between -3 and +3. So when we say absolute value of x is less than or equal to 3, that's another way of saying that x is less than or equal to 3 or greater than or equal to -3, using either this inequality notation or this interval notation. That's the same thing as saying that the absolute value of x is less than or equal to 3. So if we say absolute value of u is less than a, that's equivalent to saying that u is between -a and +a exclusively. And if we say that absolute value of u is less than or equal to a, that means that u is between -a and +a inclusively. Okay, moving along here. So if we want to solve the equation, the inequality, that absolute value of 3x minus 1 is less than or equal to 5, that means that 3x minus 1 is greater than or equal to -5, but less than or equal to 5. And then per the previous section, we just go ahead and add 1 to both sides. So we add 1 throughout, and then we divide through by 3. Okay? Divide through by 3, so that now you have x between -4/3 and +2 inclusively. And so we could use our set builder notation, or our interval notation, or even a real number line to graph our solution set. If we want to solve the inequality that absolute value of 3 minus 2 is less than 4, then again, that means that 3 minus 2x is greater than or equal to negative 4. Excuse me, it's greater than negative 4, but less than positive 4. All right, so let's solve for x. First, subtract 3 throughout, and then divide through by negative 2, which means that you will reverse the direction of the inequality symbols. So now you have x is between 7 halves and negative 1 half. Let's reverse that order. So you have negative 1 half less than x less than 7 halves. So here's your solution set in your different formats there, including the real number line. Any questions? All right, now what if we were to say that the absolute value of some number x is greater than 2? Well, it turns out that's the same thing as saying that x is either greater than 2 and less than negative 2. Okay, x is either less than negative 2 or greater than positive 2. That's the same thing as saying that absolute value of x is greater than 2. Okay, here's another way of saying it using interval notation. So you've got these 3 different ways, actually 4 different ways of saying the same thing. A set of real numbers whose absolute value is greater than 2. Expressed 4 different ways. Okay? So, if we say absolute value of u is greater than a, that means the same thing as that u is less than negative a or u is greater than a. If we say the absolute value of u is greater than or equal to a, that's the same thing as saying that a is less than or equal to negative a, or that u is greater than or equal to a. All right, moving along. So, suppose now that we have absolute value of 3x minus 2 greater than 7. That means the same thing as 3x minus 2 less than negative 7, or 3x minus 2 is greater than 7. So you have 2 different inequalities to solve. Add 2 to both sides of the inequality for both of these inequalities. Add 2 to both sides, so now you have 3x minus, or it is less than negative 5, or that 3x is greater than 9. Divide by 3. On the left, we have the inequality that x is less than negative 5/3. On the right, we have x greater than 3. And then, of course, then you could take the union of those 2 inequalities so that you have either x is less than negative 5/3 or x is greater than 3. Either in this format or the real number line where you shade to the left of negative 2 and also shade to the right of 3. Not including negative 5 halves, and not including positive 3. All right, so that's it for solving equations and inequalities involving the absolute value. All right, next section, which I'll record tomorrow, will involve solving equations in more of an application sort of environment, okay? So we'll talk with you later, and I'll see you next time. Take care. Goodbye.